Hi and welcome to Quick Chemistry. In this video we're going to look at how to choose an indicator for a particular titration. It's important to know which titration materials you're using, whether it's a strong acid and a strong base, or a weak acid and a strong base, or a strong base and a weak acid. We never use weak acid and weak bases in a titration, and I'll show you why later on. But first of all, it's important to understand how a titration curve works. So let's look at a titration curve for a strong acid and a strong base titration. So on our x-axis we have pH, and on our y-axis we have volume of our base that we're going to add. Now if I was to plot a titration curve for this, it will simply rise in pH slowly, have a sudden jump, and then continue to rise in pH quite slowly. So if we label our axes here, we might have a pH of 14 at the top, around 7 in the middle, and we'll put -1 at the bottom. And our volume of base is arbitrary, it depends on what you're adding as you go. Somewhere along the vertical line is where we will find our equivalence point. This is when we have an equal number of moles of our acid and base in the solution. Now an indicator must change colour somewhere along this line. So for a strong acid and a strong base, the equivalence point is likely to be around pH 7. However, two of the indicators that you will use frequently are phenolphthalein and methyl orange. If we take phenolphthalein in green, phenolphthalein has a pH range of 8 to about 10. This changes colour within the equivalence point line when there's a rapid change in pH. If we were to take methyl orange changes between about 3.1 and 4. Once again, the indicator does change colour within the equivalence point line. That means that either could be used for the titration of a strong acid and a strong base. If we now look at the titration curve for a weak acid and a strong base, this changes quite dramatically. So we'll start at around pH 4, and the sudden rise doesn't happen until much later. So our equivalence point is going to be around pH 8-ish. Depends on the weak acid and the strong base that you use, but our equivalence point will be in the basic region. So if we now take the pH range change for phenolphthalein, which is between 8 and 10, and we also take the pH range change for methyl orange, which is between 3 and 4, you can see quite clearly that the equivalence point will occur when phenolphthalein changes colour. So if we were to do a titration with a weak acid and a strong base, we would need to use phenolphthalein as our indicator. If we now look at a titration curve for a strong acid and a weak base, we will see that we can start quite low in the acidic region at around pH 0. We have our equivalence point line, and then it will do very similar to the weak acid but in the opposite direction. This shows the equivalence point will be in the acidic region. That also means that we cannot use phenolphthalein as an indicator, as it doesn't change colour along the vertical line where the equivalence point is found. We would have to use methyl orange in this titration. And in our last titration curve, I will quickly show you what happens when we have a weak acid and a weak base. So we'll start in the weak acid region, and it's a very similar story. There is no real line that dictates where the equivalence point will happen. Therefore, none of our indicators can be used, and we simply do not do a weak acid, weak base titration. So to recap, we can choose an indicator such as phenolphthalein for a strong acid and a strong base titration, as it has an indicator range of between 8 and 10, this means that the equivalence point will happen within that range. If we were to choose a weak acid and a strong base, we could use phenolphthalein also, because the equivalence point on that sudden change in pH line lies within the colour change of phenolphthalein. Whereas with a strong acid and a weak base, the equivalence point does not occur during the colour change, so we would not be able to use phenolphthalein as an indicator for a strong acid and a weak base. Methyl orange has a pH range of around 3 to 4, and so for a strong acid and a strong base, methyl orange would be fine as an indicator, as it changes within the equivalence point area of our titration curve. Whereas with a weak acid and a strong base, we would not be able to use it, and it would be the chosen indicator for a strong acid and a weak base titration, as once again the equivalence point falls when the colour changes. So the equivalence point is when we have equal number of moles of acid and base. So for a strong acid and a strong base, the equivalence point will be around pH 7. For a weak acid and a strong base, the equivalence point is going to be greater than pH 7, and for a strong acid and a weak base, the equivalence point will be lower than pH 7. The end point of a titration is when our indicator changes colour. We don't titrate a weak acid and a weak base, as we don't find a colour change occurring for any indicator at an equivalence point.